Hi there. This video is going to walk you through how to interpret some sample Spartan orbital energy outputs. So this image that I have shown here is a typical output that you would see in Spartan if you were to look at the detailed output after you do an energy calculation. So what Spartan is showing you here in this information is the energy corresponding to each of the molecular orbitals that have been calculated. Okay, so each one of these columns, okay, you see they're numbered 1, 2, 3, 4, 5, all the way up to 10. Okay, so we've got 10 different molecular orbitals that Spartan has calculated for this particular molecule. So it looks like it's a B2 molecule from our labels over here. Okay, so here we're going to have, again, just a molecule. Essentially, there's our Lewis structure for what we've done this calculation for. Okay, so again, each column here just represents an individual molecular orbital. Okay, so one thing we want to keep in mind is that each molecular orbital is created by the combination of individual atomic orbitals from each atom that is coming together. Okay, so each one of these boron atoms is going to contribute its own atomic orbitals, and those atomic orbitals are going to interact with one another to form these various molecular orbitals. Okay, so the nice thing about the output that Spartan creates for you after doing an energy calculation is that it tells you essentially how each molecular orbital is composed. Okay, so these numbers here are essentially telling you how much of that molecular orbital is coming from each atomic orbital on each atom. Okay, so here what we can do is to, if I just divide this down the middle, okay, where the ones become twos, so all of these are going to be coming from atom 1, and all of these are atomic orbitals that come from atom 2. Okay, so we'll call this atom 1 and that atom 2. All right, so we see that we have s orbitals and p orbitals on atom 1 that are going to combine with s orbitals and p orbitals on atom 2. Okay, and these numbers here that you see tell you exactly how much of each atomic orbital are contributing to the molecular orbital. All right, so usually what we do is focus on the largest contributors to each molecular orbital. So if we look at MO1, okay, so if we look at this column, we see that most of the contribution is coming from that 1s orbital. Okay, so we get the highest number, 0.7 there, from the 1s orbital on atom 1. And then if we look down at atom 2, okay, we see that also the most the largest contributor is also coming from that 1s orbital on atom 2. So that tells us that for that first molecular orbital, it's the 1s orbitals that are contributing the most to that particular molecular orbital. Okay, so other pieces of information that you can extract from this set of data are, if you look here at the top of these numbers, you'll see these little strange looking labels, so Sg plus, Su plus. Okay, so these tell you the type of molecular orbital that you have. So this would tell us that we have a sigma orbital that has a G designation. So remember, the G means Gerada, and U is our Ungerada. Okay, so those are just the conventional labels that we use to tell us whether or not these orbitals are symmetric or anti-symmetric upon inversion. Okay, so Garada would be symmetric, and Garada is anti-symmetric. Okay, upon inversion. Okay, so if you draw your atomic orbitals, okay, and then you were to flip them inside out with one another, that would be your inversion. And you're asking yourself, does the sign change upon inversion? Okay, if your sign changes, that's your anti-symmetric option. If the signs stay the same, that's your symmetric designation. Okay, so that's what these G's and U's represent. Okay. All right, so I hope that was helpful in helping you to become familiar with how to navigate these Spartan energy output files. We'll do a couple more videos detailing some of that, the specifics with assigning the G and the U designation. So we'll do another video focusing on that, and then we'll have another video working through a couple of example questions relating to using these outputs. So take a look at those if you like, but hopefully you found this one to be helpful in at least getting acquainted with how to use these Spartan output files. All right, thanks.